Hello. Thank you, Rakesh, for inviting me. I have a few questions for you. First one, who heard of Nvidia? Second question, who heard of Nvidia in the context of AI? Okay. So, we are from the gaming, but I come from enterprise practice where we use artificial intelligence to solve big problems. For the next 15 minutes, I'm going to share with you where I'm focusing my days and sometimes my nights. I wanted to start by something you've heard many times, the mega trends that are really imposing change in our life. First one, you've heard of urbanizations, the movement of people from rural areas into cities. We know that. Second one is industrialization. We move from farming economy, labor, to machine economy, automation, and now we're moving into data economy and AI. The third one is you, most of you, excluding me, the young generation, the demographics, that is mandating and dictating a change in the way we consume, we operate, we think of how we solve problems. That's leading to, when digitalization happened, which is the last one, mixed with the young generation, we saw disruption. Companies that have been around for 100 years do not have a capital value, $100 billion, yet companies that have been around for 10 years, they exceeded that. And that's because people are thinking differently, are re-challenging everything we know about our problems. And that's enabled by something that someone predicted 20 years ago. I think his name is Kevin Ashton, the term IoT. He predicted that we will turn the world into data. 20 years later, we are living in a world of data. Like it, don't like it, I'm not trying to, whichever side of the fence you are, this is the world we live in. And it has a lot of meanings. Now, I was lucky enough to be around for the last 20 years taking part in this transformational journey. And I genuinely hope I'll be around for the next 20 years because it's going to be exciting. But the way I witnessed this transformation is it's happening from for those who remember, all we had is a PC and a modem. And we grew up on the sound of the modem dialing in to get internet. But we moved so enough, and that was intelligence, that was smartness, that was enough for us, that was how we transformed business, that was enterprise running on that. What happened is connectivity came, 2G, 3G, 4G, Wi-Fi, now we're talking 5G, it doesn't matter, but connectivity today is pervasive. When we had both of them together, companies started thinking about, I'm gonna have my product connected. And I was in meetings with companies where I was working at the time in a telecommunication company. We need to have our product IP enabled. Why? We don't know. We'll figure it out in the future. Just make sure our product is IP enabled. Some companies understood something. They didn't know what it is. Then came mobile. That take out of the market share of the PC. And we moved into a completely different world where we started the debate of smart everything. We started seeing that word attached to everything, as if we were dumb before. The whole point is the top floor people, the IT companies, needed access to the data. They needed to go to the edge to pull the data. And the people at the edge realized that we're sitting on a minefield. We have data. We need to go up and push it to the upper level. And this is where we started seeing the IoT and the full stack happening. And startups is about mobile device, connectivity, querying, an edge device to send a request, to query the device, being a smart meter, being a smart fridge, being whatever you want. In parallel, we had the cloud and IoT becoming part of our life and at a cost that is affordable, which led to data deluge. We all heard the debate, big data, smart data, dumb data, and we debated that for years, right? 5 years ago, I think. And In that debate, we started figuring out, okay, so how do we make sense out of this data? And we moved into, let's throw buddies on it. Let's throw people that knows how to query the data. Business intelligence, and many startups built up. But we realized also with the exponential growth of data, no matter how much we throw buddies and data analysts, it's not going to scale. Luckily, and this is where Nvidia came into the game, 2010, something around 2010, the graphic processing unit, which you know Nvidia from the graphic, the many hands, by accident, by academic, we discovered that it's a parallel processing that can solve the neural networks that the gentleman before me talked about, where you feed it data and mathematical operation, neural network will process, and now we're in an era where software is writing software. That's what deep learning is all about. It's about scale, it's about machine doing the job the human couldn't do at the accuracy and the scale. So this is my experience in the last 20 years journey of being inside the smart city. Now, where does that bring me now? For those who don't know, our chipset, we have a software stack and a hardware chipset, GPU we call it, graphic processing unit, that is actually empowering everything you do today or you talk about, and in the room, I know few of you that are using this technology. We're behind the scene enabling and powering every industry. So if you're developing AI, machine learning, if you're using computer vision, deep learning, you will be using some form or shape an Nvidia chipset. My job is in one specific area, cities, and we had to choose what's the biggest problem in cities we can work on. CCTV, video. 1 billion device today in the market, 1 billion CCTV camera that is being used, archived, practically not used, because we record it. If there is a problem, we can tap to it. And that's the biggest source of efficiency and innovation that we're discovering. So we went into understanding what can we do in a market to democratize AI, to make it affordable to all those startups, academia, R&D, so they can make the magic that we're seeing today. And we started having conversation, and we started seeing a lot of discussions with companies in that space. So I'm going to use the word IVA. I mean by it Intelligent Video Analytics, if I use the acronym. The next thing we had to face is when we talked to all those people, they all requested some edge, which means they wanted the technology to be built inside the camera, inside the device, and what we call it the device camera edge. Some wanted it to be inside a premise, airport, supermarket, and some wanted it on the cloud because latency is not a big problem. So we said we have to come with an architecture that allows the three. We have to enable the market to develop solutions that can work whichever way they believe. So we came with a hardware and a software stack, which today you can download for free. It's an open source. You've heard of something called TensorRT, CUDA, and so on. You can download all these today for free and play with them. But on top of that, we said we got to work with whether it's a camera on-premise or in the cloud, and bring in the ecosystem to create the value, the secret sauce, the application on top that would solve the big problems. And our job is to help them make this possible. AI been around, someone said 1950, been around for a long time. The only difference is you needed a room this size to process a neural network, the computational power. Today, as on a chipset the size of a credit card. It's called a nano, at least in our company. I'm sure you can find equivalent. So that nano, and I'm going to show you now where we started. We took those products and we started building an ecosystem of great companies that are actually putting this vision into reality today. So today we have around 135 companies working in what we call Metropolis program. They get the software stack for free, and their job is to go do their business. Some of them are in the room here, and just do the magic from video management systems to large OEM. I'll give you some examples. To independent software vendor, these are the acronyms meaning. And what they've done is they came with solution like this. This is a camera for $600 with built-in inference. So are you familiar with the word inference and training? Yes? Okay, for those who are not, everything we talk about in artificial intelligence is made of two things. The gentleman talked about training. So you're going to train the machine on a model to do a function. This model is training to recognize plate numbers. So we feed it 1 million photos of a plate number, and then the accuracy goes up. And once the accuracy is at the level we're happy with, 97%, we package it, we containerize it, and we deploy it in what we call inferencing model. So I don't need to train anymore. I have enough. I put it in a camera, and I put the camera here. Any car that will pass, I will read the plate number. Simple as that. Now, what do I do with the plate number? It's a business process. It's a different integration. It's a different thing. You can put it to open the gate. If I know your plate number and you're authorized, you can access this car park. So I don't need anybody. If I'm shopping in a shopping mall and I have a receipt, the point of sale will alert the gate, this plate number is okay, you can go park for free. I'm just giving you random examples as we speak. And then we started seeing an explosion of ideas, which ranges from people tracking and counting, whether it's applied for coffee shops, restaurants, public spaces to understand the utilization, to see if I need to open an extra cashier. Now, today we have retailers in the UK that they have cameras, and when they see more than 3 people or the waiting between one customer and the other is more than X seconds, they open a new cashier. The manager will get an alert, and it's done. Or it's used for crowd management, whether it's a drone or a high-rise camera, and we have an event, a concert, a demonstration, whatever it is, for safety, security, for statistical purposes. We can count people, understand how they're moving, how they use space, how we mobilize the safety, the fire police to manage people. The next one is, this is from a company called Data from the Sky, or RCE Systems. This is from a company called Altenas. This one is about understanding the roundabout. Today, one of the biggest costs in cities is induction loops, if you heard of the term induction loops, which means they go to a street, they install cables on the ground, and they count the cars between one point A and point B. That causes disruption. It's not accurate. It's 70% accurate, but it's good enough. When you're making an investment of $70 and $100 million on a road, a transit road, on a highway, on a roundabout, a 70% accuracy, 30% margin of error is not good enough. Today, all you need is a camera, and you can analyze the traffic 24/7. And we have a company partner called Viva City. It's in Milton Keynes and many other places. They can predict traffic for 30 minutes ahead of time by doing and using this technology. Of course, here we look at the safety on pedestrian crossing. Now, what do you do with this data? Now, it's good to train a model to recognize dogs and cats, to recognize plate recognition, to recognize a gun, smoke, fire, to recognize accidents, to recognize anomaly like a left luggage on the street or in an airport or on a terminal, or to detect someone pickpocketing. There's a lot of models, and I have seen a lot. I'm lucky because I work with amazing people, those startups, and I've seen them develop a lot. But the challenge is, what do they do with this model in a business context, in an environment where they can deliver an ROI to customer? So a supermarket would say, at the point of sale. I have a lot of mis-scanning, pickpocket, hiding and scanning. We call it sweethearting. The cashier knows the cousin passed 2 items instead of 1. They brought startups, and now it's solved. The machine can learn to detect anomaly, abnormal behavior. And the gentleman before me talked about it. If you teach the machine what's a normal point of sale checkout, what's a normal shopping is, and what is an abnormal behavior, that's it. And then when you run in parallel this camera and you show what is happening, the return on investment in that case was less than 4 months in one shop. So in that first one, we're seeing where the data of counting cars on crossroad and turnabout becomes heat maps. Are the cars, this is, by the way, a 24 hours video condensed. That's why you see them going on top of each other. So it's a synopsis. You start creating a heat map, and are they using the space as we planned it? So we learn how to plan better. Are the cyclists, the pedestrian, and so on and so forth. Now, on this one, we have 2 applications: car parking wardens and police cars. If a police car is driving and they have a wanted vehicles, today they inspect visually. All they need is to put 360 degrees cameras on the rooftop of the car. And this is a solution that exists today with a company called Ekin, for example. And it will detect any plate recognition wanted car, basically. The next one is, this is our car park. If you download DeepStream today, you get this built in. This is our car park. You don't need barriers. You don't need security. If we go as an employee and we register, this is in Endeavor in Santa Clara. So then your vehicle is tracked as authorized. If it's not, the security guy that's touring the campus will come and check what are you doing here and so on. Here, if you saw it before, in a 24 hours, I'm interested in bicycles that are turning right. I'm just using an example here that we asked for. Then you can count all the objects that are turning right. So the power of AI is simple. What do you do with it is up to you. But think about it this way. If you can see it with your own eye, if you can interpret it with your own eye, the AI can do it faster, more accurate, at a scale and speed you can never imagine. That's basically how I describe the intelligent video analytics today. My prediction is very simple. The debate of AI, it's not a matter if it's going to happen. It is happening. There is a pessimistic view and optimistic view, and both of them are valid. How do they coexist together? We're going to have to accept the strong possibility in 10 years. We're going to have digital twin, which we saw earlier when this model, you put your friend's name. This digital twin, it went on the web and pulled all the data. You all have digital twin today. You all have your footprint today on the web, from your Facebook to your Twitter to your Instagram to your Wikipedia, whatever you have, to your blog. So you have your footprint there, and it will keep developing. Now, this model is going to migrate to become in a physical entity. The digital twin will merge with robotics, and we will have it walking between us. The question is, between now and that, whether it's 10 or 15 years, is what are we going to do to regulate and to enable this to coexist in a way that is more positive than it is negative. It could be negative. Thank you.